Hello everybody, welcome to Chapter 8. This is one of our next to last chapters in which we're using what we've learned about probability in the normal distribution, and we're going to get some inferences about populations based on our samples. And that's the whole purpose behind what's called a confidence interval for one population mean in this chapter. So in Chapter 8, we'll talk about what a confidence interval is and how that's going to help us determine some information about what's true about a population given a sample taken from that population. Remember that one of the questions that we asked at the beginning of this course was we asked whether or not it was possible for us to take a small sample and infer something about that entire population. And this seems like a very counterintuitive thing. Most people who pay attention to political polling understand the idea that if there is a poll of 1,003 people and they infer that the popular vote is going to be for one candidate, then that's for the entire population. How are they coming to that conclusion? And how do they know they're right? Of course, we've had some indications that sometimes this isn't always a perfect system, but depending on the sampling method and the way that we go about it, if we've done all of our information correct, it is indeed the case that we can get an estimate of what that population is going to look like based on a sample. So let's talk about estimating a population mean. How do we actually estimate it? Well, let's go through the steps. First of all, we go through and we determine how we're going to sample that population, right? How we're going to get some information about that population, because it's impossible outside of an entire census to go through and ask every member of the population something about their height, their weight, how many people live in their household, you name it. When we go through, then, we have to rely on a sample and what a sample can tell us. And one thing that a sample tells us right away is what's called a point estimate. A point estimate of a parameter is the value of the statistic being used to estimate the parameter. Well, what do we mean by that? Well, a point estimate, if I go through and I sample 100 U.S. male adults and find out how tall they are, and I find that the mean height is 69.5 inches in that sample of 100 adults. How accurate have I been? Well, that 69.5 inches, if I say, well, that's the average for the adult population of males in the United States, then I have just made a point estimate of the entire population. That is the parameters. The parameter that we're discussing here is height of males in the United States, and that parameter is being estimated by the point 69.5 inches. It's a statistic. But is that a really good statistic? How do we know that we're right? What if our sample of 100 was faulty? How far off is far off enough? And that's the reason that we use what's called an interval. If instead of saying that the height of all males in the United States is about 69.5 inches based on my sample of 100, well, I'm probably going to be wrong. But if I say something like this instead, that the height of males lies somewhere between 68.5 and 70.5 inches, I might be a little bit better off. And that interval, that 68.5 to 70.5 inches, might actually be an interval that would be useful in saying that the entire population mean height would be somewhere between those two values. And we call that interval a confidence interval if we can then say we have a 95% level of confidence, or some other percentage of level of confidence, that that's true. So a confidence interval is an interval of numbers obtained from a point estimate of a parameter. In other words, we go through and we take a sample and we come up with an interval based on that sample and what we know about the population. That is our confidence interval. Now, the level of confidence, when I said we are a certain percentage confident that this is true, the confidence that we have that the parameter lies within a confidence interval, that is, the confidence of the interval actually contains the parameter. And this is going to go to dealing with our normal curve and what that means. Finally, we use these two ideas together to come up with our confidence interval estimate. That is, the confidence level and the confidence interval together make up what we call our confidence interval estimate. An example is a really helpful thing to see. So let's consider this situation. Let's say that 25 consecutive confidence intervals for the mean price of all new mobile homes, each based on the sample of 36 new mobile homes, is shown in this figure right here, this table, and these things. Let me illustrate what we've got right here. If we check out these levels right here, we see that let's say that in sample number 1, we took 25 samples, right? So we went through and we just did this experiment 25 times. We went through, took a random sample of 36 new mobile homes and looked at their costs, right? So let's say the mean price of these mobile homes, in let's say thousands, right? Let's say we had a mean in our sample 1 of 63.45 inches, right? So here it is, 63.45 inches right here in the center. If we look at the endpoints right here, we said we developed what was called a confidence interval. So somebody went through and said, okay, we're 95% confident that the actual population mean will be somewhere between these two numbers, 63.05 thousand and 67.85 thousand, right? This interval, then we say contains, or we're 95% confident, contains the actual population mean. Now let's say that through some quirk of history here, we've actually gone through to some mobile home database and found the actual population mean of those mobile homes, right? The population mean being 65,000. Let's just say that we happen to know that's actually the case, right? Well, we go through and with these samples, then we take a sample of size 36 from all of those possible mobile homes. We find another sample. This time, the sample mean lies somewhere on the interval from 61.81 to 66.61. We're 95% confident that the actual population mean lies within those endpoints, within that interval, right? So saying 64.21 is the mean price, well, that's our point estimate, but we're really interested in the interval estimate. You know, what interval do we think that the mean price will be in, right? So if we look all the way down the list and we look at all of these, are all of the intervals ones that contain the population mean? No, right? Let's say if we took 100, if we're saying we're 95% confident that all of our samples will contain the mean, well, that means that there's a 5% chance that we might not be. Right here, we see one that's not, right? This one doesn't contain our population mean, right? But we see that, well, 95% of the time, pretty much, right? 1 out of 25 right here is in fact correct, and that fits with our idea of a confidence interval and what that tells us. So our job here in this section is going to, in this chapter, is to go through and let's find a way to develop our own confidence intervals based on what we know about sampling intervals, and our newly acquired information from Chapter 7, which was on population means and our sampling mean, right? All those kind of good things. So we'll come right back to this.